All right, everybody. So with what we've been working on this week with graphing linear equations and talking about how to do things in slope-intercept form, where we want to start to focus is any kind of real-world applications for those. So what I need you to do is go ahead and make sure that you have your notes for Call the Plumber. And we're going to go ahead about how to actually interpret and graph those linear equations. So on our first one, Pete is a plumber. He charges $15 an hour, plus $30 to make a service call. Carla's a plumber and she charges $25 per. So what we want to do is we want to write an equation in slope-intercept for each person. So if Pete is going to do 15 per hour plus 30 to make a service call, his is going to be y equals the $15 an hour plus 30. And then per hour is going to be your x. Carla charges $25 an hour, so hers is going to be y equals $25 an hour. And then there's your per hour, your x. So tell what the x variable represents in your equation. Well, the good news is for both of us, it represents the same thing. So x is the number of hours. Tell what the y variable represents in our equation. Well, our y variable is going to be y is the cost of the service call. So, as you remember, our y is going to be our y-intercept. So, cost of the service call, B, sorry, I think I said y. B is your y-intercept, and that's your cost of your service call. So what's the coefficient for each one? Well, for Pete, his coefficient is 15, because he charges 15 per hour. Carla charges 25 per hour. Now there's our y-intercept. Maybe I'll get it right this time. The y-intercept, the beginning value for each one, if you think about it, Pete is going to charge you $30 just to show up at your house. Carla is only going to charge you per hour. So her y-intercept is 0. Now where we want to go from here is we want to create a table and we want to graph our information. So I'm going to have to do a little sliding here back and forth because it's not all going to fit on the screen at one time. So important thing number 1, complete a single table and graph it to show how the prices are for each plumber. I want to go from 0 to 10 hours, going up by 1 hour each time. So what we're going to do to start with is we're going to do our hours, and then I'm going to have Pete, and I'm going to have Carla. Okay, so really specific, when it does give you directions for this, you want to follow really carefully. So show prices from 0 to 10 hours. So my hours, I want 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we're going to talk about our cost for each one. So if I know that Pete is going to get $15 per hour, but he's going to charge me $30 to show up, as soon as Pete shows up at 0 hours, I owe him $30. Now, after 1 hour, I owe him 45. 2 hours, 60. 3 hours, 75. 4 hours, 90. 5 hours, 105. And then 120. 135. 150. 165, and finally $180 if Pete happens to work 10 hours. Carla, a little different opening value. Since she does not have a B, she does not have a y-intercept, it's proportional. Carla at 0 hours earns $0. $25 per hour, so there's 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. So I know I went a little quick. If you need to pause on that, fine. But it is incredibly important that you do not get in a rush when you are filling in those tables. Because if you throw off the table, more than likely you're going to throw off your graph. Okay, so where we want to go now is we want just a little refresher before we start working on this graph. One of the things that you're going to do in math and also in science is you're going to use what we call great graphs. So, when you are talking about a great graph, these are the ideas that you want to follow. So what we want to do with a great graph is you do want your graph to be 75% of your workspace. It's not an exact thing, you just don't want it to have a super tiny graph in a big space. The second part is you need the right variable, and that means your independent and your dependent variable, are they in the right places? E, equal interval. You want an equal interval on both your axes. The A, you need to make sure that your axis is labeled. And then a very large one also, T, you need to make sure that you have a title. Something that's going to reflect your data. So let's go ahead and we're going to use our graph space down here. And we'll come up with just something incredibly flashy, like plumber cost. So now I have a title on this. And in this case, my hours is my independent variable. It's the one that's going to control things. The independent variable is going to go on our x-axis. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for the hours. And then we'll go by 25s on this. I'm sorry, I'm going to go back just so I don't forget and label that. 75, 100, 125, 150, 175, 200, 225, 250. And that is going to be my cost in dollars. Okay, so I'm going to go ahead and graph Pete. So at $0, Pete is at 30. At 1 hour, it's at 45. 2 hours, it's at 60. 3 hours, 75. 4 at 90. 5, 105. 6, 120. 7, 135. 8, 150. 9, 165. And 10, 180. We want to take some kind of straight edge, and I want to go ahead and connect the dots for our plumber Pete. Okay. Now it should be just a little easier for us to do Carla. So at 0 hours, Carla earns $0. 1 hour, 25. 50, 75, 100. Oh, sorry, I'm off on that. 4 hours is 100. 5 hours is 125. 150, 175, 200, 225, 250. And we'll go ahead and we will make sure that we have Carla connected. Another thing that, even though we did it in the table over here in terms of color, I would always make sure that I put some kind of key So for this, the blue line represents Pete. Your green line represents Carla. So the next thing we want to do, guys, is we want to go ahead and we want to start interpreting our data. So the nice thing is we definitely have good linear data. For how many hours is the cost the same for both plumbers? So if you look at your graph and your table, you're going to notice that for both plumbers at 3 hours, they both charge $75. So there's a point of intersection on the graph and also the same number on the table. So for how many hours is the cost the same? 3 hours. It's also really helpful when you can interpret this, because you can take that linear data and you can go ahead and you can come up with a rationale. So who's the best for your friend? Well, really simple. If, I know this says 3 complete sentences, but we're going to make it just a little shorter. If your job is 3 hours or less, Carla is the better deal. If your job is more than 3 hours, Pete is the better cost. Okay, so what we're going to do now is we're going to use those linear equations and we're going to solve these problems. And this is going to give you a chance to plug it in and solve for the equation. How much would each plumber make if they worked for 5 hours? So let's do Pete first. Okay, I'm going to go ahead and do my work out to the side here. So Pete is y equals 15x plus 30. And I know that we're talking 5 hours, so y equals 15 multiplied by 5 plus 30. Y equals 75 plus 30. So y equals $105 for Pete. Okay, let's go ahead and do Carla. So for Carla's equation, we want y equals 25x. Y equals 25 multiplied by 5. Y equals $125. So what we're going to do now is we're going to know our total cost, and we're going to solve the equation to figure out how many hours. Alright, let's go ahead and do Pete first. So we're talking about making $150 equals 15x plus 30. Now we're going to go ahead, we're going to solve our equation. Subtract 30, subtract 30. So 120 equals 15x. Divide by 15. So x equals 8. So we're talking about 8 hours for Pete. Okay, now it's Carla's turn. So same thing, $150 equals 25x. Inverse operation, divide by 25. So x equals 6 hours. So I'll go ahead and we'll fill in Carla's. Okay, here's our last one. So if this was our equation, y equals 35x, then you and I know that that would be $35 per hour. Y equals 20x, $20 per hour, and $75 to show up. And lastly, y equals 125, so that's a zero slope. It would cross the y-intercept at 125. This just means a flat fee of $125. So if you have a job that's going to take 7 years, get the y equals 125.